The best model fit for the DNA sequence for the AIC criterion is GTR, because for AIC, the model with the highest amount of variation and the least amount of independent variables. So that highest number is what you want. And then for the BIC, the best criterion is JC69, because it's the lowest number for that. For this genetic tree, the most closely related to my bacteria are the B716F, B316F, and A5 16F are the closest, because when you look at the tree, what's highlighted in orange is the closest, because the branches are different points in history where they separate. So the less branches, the closer they are related. With this, you can see it just gives more detail with the numbers for the different branches on the phylogenetic trees. The higher the number is on this, the stronger the evidence. The sequences to the right of the nodes will cluster together. But this just gives more specific numbers for the 16F DNAs. For the site frequency spectrum analysis, it shows what parts of the DNA sequence evolved naturally. So like a mutation occurred that would be naturally, versus unnaturally would be like some form of natural selection, like bottleneck or human involvement or whatever. For my spectrum analysis, it shows the DNA was not evolving unnaturally. So any evolution in the specific DNA occurred with mutations and such. The substitution rates, the shape of the gamma distribution determines the skewness of the results. So because there's a increased amount in density around the 0 mark there, it's skew right. So that means that there is a slow evolutionary rate within this specific DNA that, it's not a fast evolving bacteria. And the molecular clock test, the Shapiro-Wilk test shows if the data is in a normal distribution, and with these results, it does not seem like the DNA is evolving in a circular way or evolving in a loop, which just means like it's kind of re-evolving, I guess, is the simple terms.